Okay, this is the last part for the perfect squares, I promise. So in that previous example, I explained the general process. Now let's practice it a little bit, and I think that might help because that might not have made a ton of sense. Let's factor, let's see, p squared minus 14p plus 49. All right, so for your test, the first thing you need to do is look at the ends and see if those are perfect squares. So you want to say, ask yourself if 49 has a square root, and it does. So that one passes the test, so write the square root in a little parenthesis squared. Does p squared have a square root? Yes, remember you take half of the exponent, so it's p. So that passes the test. Put it in the parentheses squared. Now, to check the middle term, you multiply the parenthesis pieces, just the inner parts, 7 times p, then multiply that by 2, double that. 7 times p doubled is not squared, doubled, is 14p. Then look to see if that's 14p. It is, then the middle term checks out. So you're going to get in one parenthesis squared, this first piece. This sign here, the very first sign is the sign that goes in the factored parenthesis. Minus, minus, and then this piece, 7. So factored, it's p minus 7 squared. All right, example 3. Let's do x squared minus 20x plus 100. All right, first let's see if it's a perfect square. We have to check the two ends to make sure they're squares. So does 100 have a square root? Yes, so I'm going to write it in a parenthesis squared. Does x squared have a square root? Yes, I'm going to write it in a parenthesis squared. So the ends pass the test. Now we've got to see if the middle term passes the test. The middle term should be 10x doubled, which is 20x, and that's what it is. So the middle term checks out. That means it factors, and when you factor it, it looks like this. 1 parenthesis squared, x, this first sign goes here, and 10 is the last. All right, example 4. Hopefully you're getting it a little bit better now. It will take some practice. What was that, 3? Yeah. Example 4. Okay, how about 4x squared plus 12x plus 9? Now, check the two ends. 9 is a perfect square, so I'm going to write it in a parenthesis. 4x squared is a perfect square. His square root is 2x. I'm going to put that in a parenthesis, so the ends are perfect squares. Now let's check the middle term. It should be 3 times 2x, that's 6x. Now double 6x, 12x. That is 12x, so the middle term checks out. That means it factors. That means it's a perfect square, and therefore, here's how you put it into the factors. 2x. First sign, this sign here, right, is this sign here. That gets forgotten quite a lot. And I'm just going to put a little arrow showing Europe. There we go. And 3 goes here. Okay. Hang in there. Example 5. Let's do this. X squared plus 5x plus 25. Okay, testing the ends first. 25 is a perfect square. X squared is a perfect square. right? I put the square root in the parenthesis with the squared on the outside. Let's check the middle term. It should be 5x, multiply the inner parts, 5x doubled. That means this should be 10x. 5x doubled is 10x, but it's not. So this fails. The middle term does not work. It's not a perfect square. And plus there's no GCF or anything. I can't factor this at all. Therefore, it means it's already prime. So you would say prime. If it fails, not a perfect square. Fails test. Okay, example 6, we're almost done. Let's see, we did, here, we'll do this. X squared, I don't think I did this one already, it sounds familiar. Oh my gosh, I actually did. Okay, let's do 9x squared minus 12x plus 4. All right, 4 is a perfect square. 2 is the square root. 9x squared is a perfect square. 3x is the square root. Check the middle term. 3x times 2 is 6x, doubled is 12x. That needs to be 12x, and it is. I'm not worried about the sign, just look at the term. That means it's a perfect square. So to factor it is 3x. First sign, 2. There we go.